Chapter 5.2 Wave Phenomena, Reflection and Refraction. Let's begin. What are waves approaching the shore? Waves approaching a beach is always parallel to the shore. It is not a coincidence, but it is due to the physics phenomenon. It is due to wave refraction. You can find an explanation at the end of the chapter. We will continue to use water waves to demonstrate different wave phenomena. 1. Reflection of waves. Let's take a look at the following experiment first. Experiment 5b. Reflection of water waves by a straight barrier.
We will see how water waves are reflected in different situations by using a ripple tank. First, send straight waves towards a straight barrier at an angle. Then, vary the incident angle by rotating the barrier. Observe how the reflected waves are affected. How is the angle of incidence related to the angle of reflection? Send circular waves towards the straight barrier. Observe how the waves are reflected. Where do the reflected circular waves appear to come from? Send straight waves towards a concave barrier. Where do the reflected waves appear to come from? Send straight waves towards a convex barrier. Where do the reflected waves appear to converge?
We can see quite clearly how water waves are reflected by a reflector or barrier. The straight wavefront is reflected as straight wavefront, without change in shape but only direction of propagation. And wave reflection follows the laws of reflection, which includes angle of incidence equals the angle of reflection, and the incident and reflected wave lie on the same plane. There are two different ways to mark the angles of incidence and reflection, both equally important. One is to mark the incident ray and reflected ray first, then mark the incident angle and reflected angle mixed with the normal. The other is to mark the incident angle and reflected angle this way, between the wavefronts and the reflector. Apply the following skills to draw wavefronts in reflection of waves. Also note that reflection does not change the wave speed, frequency, nor wavelength of the wave. This simulation shows the reflection by a straight barrier. When straight rays are reflected, the wave speed, frequency, and wavelength are unchanged, but the direction of propagation changes. The reflected waves appears like coming from an image behind the barrier. And now for circular waves. When the circular waves hit the reflector, it is reflected. The reflected wavefront appears to come from an image behind the barrier again, at the same distance from the barrier as the object is. The following simulation compares the wave model and ray model of waves. For point source, the waves spread out as spherical wavefronts, while the rays, they travel radially outward from the point source. For parallel beam, which comes from a distant source or an extended source, the rays are parallel, while it is represented by straight wavefronts traveling from one side to another. For reflection, both are point sources. In the ray model, the rays are reflected according to the laws of reflection. In the wave model, the wavefronts are circular and they are reflected, and it appears to come from a point behind the barrier, which is the image. B. Reflection of circular waves. For circular wavefront, it is reflected, so an image is formed behind the reflector. If you are asked to draw the reflected wavefronts, you should better locate the image first, as the skewed section shown below, and then you may draw the incident wavefront and the reflected wavefront as shown here. And don't forget to connect the reflected and virtual wavefronts. And now do check point 2 on the next page.